Good morning, everyone, and welcome to our webinar on the revision of BS 4877/2016, which sets out a code of practice for nuclear reactor and instrumentation and control. Today, we're here to discuss BS 4877/2025, which is the revision to this standard and is expected to be published in early 2025. In today's session, we will cover why there's a revision, what has changed from the 2016 publications, and some specifics on the standard, and then a more broader context. I'm Seb van Doord, BSI's Director for Energy and Sustainability, and I'm delighted to see so many of you here today, and I'm very pleased to be chairing today's session. It's a short session but important discussion on BS 4877/2025 and the broader role of nuclear standards in advancing our energy goals. It's an exciting time for the nuclear energy, and it's fantastic to see such expertise gathered here to explore the future of this industry. So recent announcements in the UK have made it clear nuclear energy is once again at the forefront of our national and international conversations, with the UK government's commitment to expanding nuclear capacity as highlighted by projects like Hinkley Point C and Sizewell C. I thought it was interesting to note in recent developments is the announcement of tech giants like Google, Microsoft and Meta, who are all investing and looking at small modular reactors to meet the growing energy demands of artificial intelligence and the data centers that powers it. So this underscores an increasing recognition of nuclear as a critical energy solution to deliver low carbon energy. As the first country to legally commit to net zero by 2050, the UK really sees nuclear energy playing an important role. This commitment has been reinforced by the Labour government's pledge to decarbonise the power grid by 2030, which is no mean feat. So achieving net zero is not just a high ambition, it's an urgent necessity. And to decarbonise the power grid, we need a dependable mix of low carbon energy sources, and nuclear energy is a vital part of that mix. It provides the stable base load power that complements the intermittent nature of renewables like wind and solar, thus helping us to balance energy supply with demand. And in this sense, nuclear isn't just an option, it's a cornerstone for decarbonising the grid and achieving our climate targets. So where does this standard BS 4877/2025 fits in? Well, the importance of clear, effective standards in nuclear reactor instrumentation and control cannot be overstated. This standard ensures that our approach to control systems is rigorous and aligned with international best practice, helping us to safeguard both the environment and public trust as we look to scale up nuclear capacity. So in today's discussion, we'll dive deeper into this particular standard and how it aligns with the industry's evolving need. In order to discuss this in more detail, we have invited two experts. We've got Robin Shirtcliffe, who is a Senior Manager for Reactor Protection Control and Instrumentation Systems Design at Rolls-Royce SMR, and he has over 27 years of experience working in the nuclear industry. We also have Guido Vilas-Rivas, who's an instrumentation control and cybersecurity lead at EDF Energy, who will talk more about cybersecurity. So this session will be fairly short and take about 30 minutes, although as the chair I can say that we're probably going to go over a little bit, so somewhere between half an hour and 45 minutes. We'll start with a presentation from our panelists, and after this we'll move on to a very quick Q&A. But before I hand over and welcome our experts, allow me to set a little bit of context of BSI and who we are and what we do. So just a little bit of housekeeping before we start. This is a listen-only webinar. This is being recorded. We welcome any of the questions that you have via Q&A function, which will be answered during the webinar. Simply click the Q&A button on the side and post your question. If you experience any technical difficulties, please submit your issue or a description of that in the Q&A function as well, and our team will hopefully support you to resolve your issue. We will also send out a recording, and with a little survey, once you complete the survey, you can get access to this recording. Next slide, please. So this is the agenda. I'll provide a little brief introduction. I'll briefly jump into who we are as BSI for 5 minutes, and then I'll hand over to Robin and Guido. I just need to check, because I think there might be some technical problems with Robin, so I might hand over to Guido first if there are any issues. But then we'll conclude with a Q&A around sort of 10:25 and look to conclude around 20 to 11. There you are, Robin. I'll just go into my presentation for now very briefly, and then I'll invite you in, Robin. So just a brief overview of who we are as BSI. So we are the UK's national standards body. Robin, do you mind just briefly going on mute? I think there's a tiny bit of background noise. But we are the UK's national standards body. We are independent from government and industry. In most countries, there is one national standards body per country. I think the US might be slightly different, but most countries have one national standards body. We're the one for the UK. We are independent from government and industry. We're a not-for-profit, or as we say, a profit for purpose, and our purpose is standardization needs and really supporting that work. We have an MOU with government, and what profit for purpose means is that all the money that we generate does not go to external stakeholders, but it goes back into our organization to support its future standardization needs. Our standards are market-led, so BSI will never say we need to develop. We need to develop a standard. It's the market or industry that will say that they need a standard, and all our standards are developed from consensus and consultation process, and that's how they get their legitimacy and the reputation. Standards are always voluntary and they sort of help best practice, but they can be referenced in regulation, and they build trust and provide assurance. And one of the key areas in my role is to ensure that we position standards so that they support and help to deliver government policy outcomes. Next slide, please. Sorry, next slide, please. Thank you. So just to highlight, we are part of an international standard system. We are the UK's national standards body and represent the UK at international standards bodies like ISO. We are a founding member of ISO, but also the other regional standards bodies that you can see: IEC, CEN, CENELEC, ITU, and ETSI. Next slide, please. So standards are part of a global system, and just to highlight, as we've mentioned, standards are created through a consensus-based process. At the top, we have international standards, ISO standards. You're probably familiar with ISO 9001. Below that, you've got the regional standards that are very much sort of European standards, part of CEN and CENELEC. And then we've got national standards like British standards. We also have fast-track standards, PASs and flexes now as well, which can be created in the space of 12 months, and those are very much created for those emerging, fast-moving areas, very often helping to deliver policy outcomes, but where we need a standard in a short amount of time. As we've mentioned, standards are part of an international system, and they get created via a consensus-based process. So if you want to create an ISO standard from scratch, you have to reach consensus in 170 countries. Sorry, can somebody else go on mute as well? I'm hearing some beeps in the background. And fast-track standards take anywhere about 9 to 12 months, and those fast-track standards can often be used to be a seed document for international standards. Next slide, please. Sorry, next slide, please. So just to be clarify, there's often a lot of questions and misconceptions around standards, but there are a number of different standards that we have, or types of standards, that are all classed as sort of standards. So a standard could be a specification, which is something that sets out the detailed requirements, very often something to be satisfied by a product or material or a process. We have a code of practice, which we're looking at today, which gives recommendations for accepted good practice and brings together the results of practical experience by experts. A standard can also be a guide, which gives more broad and general information about a subject. And then there is a test method, which sets out the detailed procedures for performing an activity. Those all encompasses what we would class as a standard. Next slide, please. So the value of standards, when we look at standards, and particularly international standards, they have global recognition. If you have an ISO standard that is accepted in I think it's 171 jurisdictions now, it's a unique approach by having a consensus-based model, which includes involving experts from around the world to develop these standards. They provide or support independent assurance, and they have real-world economy adoption. And they are the backbone to facilitate trade. Next slide, please. So just starting to conclude here. So, as we've mentioned, the work that we do often aligns with international standards. The work that we're looking at today and the standard that was created by NCEA, the Instrumentation, Control and External Systems of Nuclear Facilities Committees. It has an interaction with CEN and CENELEC with CLC TC45AX. Next slide, please. And under the direction of that, we have these stakeholders that all sort of are part of that particular nuclear committee. So I think that's enough from me. I now want to bring in Robin Shirtcliffe. As I mentioned, Robin is a senior manager for reactor protection and control and instrumentation systems design at Rolls-Royce SMR. He has over 27 years of experience working in the nuclear industry, and he's responsible for the design of control and protection systems for reactor systems, and as such has experience of working with diverse stakeholders within the industry. Can I bring you in there, Robin?
Morning, everyone. I trust you can hear me. Yes, I've got about 5 slides to take you through. So this part of the presentation is really about the latest up issue of the 4877 Nuclear Reactor Instrumentation Control Code of Practice. This slide is attempting to put that into context with everything else. So as we've just heard, this is a national standard and is written by NCEA Group, this standard is the only standard that we write and author completely. The rest of the committee's roles are around supporting IEC standards and making sure that we have agreement on those. So why did we decide that we needed to write this additional document? It puts into context the international standards into the context of the UK regulation and best practice as seen in the UK. For that reason, it was felt that it was a worthy document, and is now in its 3rd issue, or will be once the final consultation results in the issue. Next slide, please. So yes, reason for update. So it was updated in 2016, which in terms of standards wasn't that long ago. But a lot has happened since 2016 in the nuclear industry. We decided that this document is still very relevant and value to authors, to the readership, and decided that we wanted to keep it up to date. Lessons from before was that it sat and was out of date, and it took a lot of time to update. So this time we wanted to keep it very relevant and improve and reissue it to with the 8-year window. Latest guidance. So it brings in the latest guidance from a range of issues that have developed over the last decade. It amends the sections on computer-based systems, programmable systems, and aligns that better with UK expectations in terms of the regulators' expectations. It also includes guidance on cybersecurity, an area that you'll hear more about in a moment through Guido, and an area that is fast moving at the moment. So it's important that everyone is aware of those changes. And other international standards have changed in that period, so we just wanted to make sure that all the references and guidance were in line with those latest IEC standards and good practice. And as I said, its relevancy and wanting to keep it relevant, there's lots of lessons learned from the Hinkley Point C construction and latterly Sizewell C, and we also wanted to make sure that it supported British nuclear revival, the new technologies that are coming our way. So on the right hand side is a slide courtesy of the government's roadmap to 2020-2050, which recognises that there's a number of nuclear technologies that are either in operation or in design phases. So we have large-scale nuclear reactors, the likes of Hinkley Point C. We also now have more interesting small modular reactors, which is what I'm working on at the moment. And we also have advanced technologies as well that are also being developed and starting to be seen around the world as well as operational. Next slide, please. Okay, so what does 4877 do and who's it for? So it's intended to be a readable standard that covers the whole sector, so it's got quite an ambitious scope, and it attempts to bring that into UK relevancy, bringing in experience and best practice from the UK. It's intended for anyone really in technical and safety management, so people who might not be I&C or C&I experts, and or people with C&I design experience who just want a summary of UK codes and practices. It does not replace, or it's not intended to replace, the whole scope of IEC standards. It couldn't do that, and it doesn't necessarily stop the need for C&I practitioners to understand the much more detailed definitions and advice and requirements that come from those standards. Okay, next slide. Okay, so what does it include and what doesn't it include? It includes the all I&C design systems and measurements required for the nuclear reactor plant. It includes specifically those systems that are required for safety and protection, but it also includes automation and discussions around what is needed for the main control area. So it includes HMI requirements as well. It incorporates or tries to explain within the UK reference the life cycle that is expected through design and implementation of those systems, and documents those activities. It does not attempt to cover all of the commercial or managerial requirements around design, and it can't necessarily provide all context around a specific design for specific faults that are related to individual design concepts. It's supposed to cover multiple technologies and therefore keeps things at a kind of principled level. And it doesn't necessarily include all of the kind of support and auxiliary functions and systems of a plant. So it doesn't necessarily cover refueling systems and ECCS and other things that are all equally as important to the overall safety case. Next slide, please. I've put the structure up there. It hasn't necessarily changed since the last issue. It starts with those basic principles, explains the kind of systems you'd expect within an I&C architecture within the overall system of systems. It provides more detail on the reactor plant instrumentation, and then goes on to talk about secondary circuit turbine systems as well, and then the detailed design recommendations. And I think it's worth pointing out the Annex A. I think that's quite a useful resource. It lists all the relevant national and international standards, but also provides a summary of the content of those, or at least just a brief description, which helps anyone who wants to go into more detail. The structure of the document is quite interesting. It provides should statements and also includes in italics commentary and explanation that helps provide a little bit more context around that. I think that makes it quite a readable standard. And next slide. This just summarizes, so for people who are aware of the current issue and want to just understand what we've changed, this provides a very high level summary of those changes. We've changed some phrases and descriptions within 515, recognizing the wider context and importance of equipment health monitoring and plant-wide analysis within in order to keep the CNI operation on the plant safe. As mentioned, it recognizes and 8.1 has been updated to cover the latest experiences and regulatory expectations, and includes some references to cybersecurity. There's another section on EMIT or EIMT, so this is additional guidance on testing and updates the Annex A. Next slide, please. And that's a very quick canter through the changes and the context of the standard. So I'll leave. I'll move you on to Guido.
Brilliant. Thank you very much, Robin. That's really interesting. Really interesting to where you highlighted sort of Annex A, the relevant links and summary of the content of those standards. I think that's something that is actually really useful where you have that little summary. Guido, can I ask you to turn your camera on? Oh, brilliant. Thank you very much, Robin. So Guido, just to introduce you there, Guido Vilas Rivas is an instrumentation and control cybersecurity lead at EDF Energy. He has over 20 years of experience in the design and deployment of operational technology in critical national infrastructure, working as an operational technology supplier as well as an operational technology user. And I think you're going to talk a little bit more about cybersecurity. Is that right, Guido?
Yes, thank you, Sebastian, for the introduction. I hope everybody can hear me okay. And yeah, thank you to BSI for having me today. I had the opportunity with a few colleagues to obviously contribute to the new update to the standard with the cybersecurity section, which has been noted already that it was one of the most significant, perhaps, changes in this version of the standard. So obviously during my short presentation, what I will do is I will just summarize that section and share with you the key points of that section. So starting obviously with what we see on the screen, I think this is about the reason why we or the committee decided that we need to address cybersecurity, as before it was not really addressed. And I think this point here is probably are very well known to most, if not all of us today in this webinar. We have mentioned a few times about the evolution of the INC systems into systems that contain more and more software, simply because the fact that obviously using conventional technology is becoming increasingly difficult. And also the fact that the software is now everywhere. If we look at the nuclear plant instrumentation and control, it's quite difficult actually to find today areas where we only have conventional equipment. So including smart devices is one of the areas, for example, where software is increasing. The other thing is obviously interconnectivity. We build plants obviously to produce electricity in case of nuclear plants. So the business wants to have access to data from safety systems, from control systems. The systems themselves, because the plants are very complex, need to be interconnected, exchanging information. So that obviously brings an additional challenge when it comes to cybersecurity. We already probably hear on daily basis, or at least on regular basis, about the risks around the world with different threat actor groups, nation state sponsor groups who are interested in compromising critical national infrastructure around the globe. Obviously, UK is not different. We are also concerned about. We also are seeing specific attacks or specific software that is being developed specifically to compromise operational technology or INC systems. And this is likely to continue to develop. So therefore, there is a need now that when we look at the INC systems safety and control used in the nuclear plants, we need to make sure that we are prepared to address these concerns. So obviously the conclusion is that today, and it goes back to the expectations, including the expectations from our regulators, that cybersecurity is just an integral part of the INC safety design lifecycle, and that's what I was trying to show in this little figure that is on the right of the slide, where we are saying until now, whenever we were talking about deploying an INC system into a nuclear facility, we were putting quite a lot of effort in terms of qualifying that system using different techniques, including hardware qualification, but also software qualification. So now we have this additional leg, which is called cybersecurity, which is effectively an intrinsic part now of the overall safety justification. So if we go to the next slide, please. Next slide, please. Thank you. It's a bit of a busy slide, but you will be glad to know that I have only two, so this is the last one. This is just summarizing, obviously, the main points that have been captured in the standard, which Sebastian and Robin were summarizing. So these are recommendations and probably the starting point if you are thinking about cybersecurity. And effectively, and in summary, what the standard is trying to communicate is that when it comes to deploying INC systems, safety and control in nuclear facilities, we should be thinking alongside the safety life cycle. That is something that we already do today. We need to start thinking about adding what we call the security life cycle, which should be running in parallel, and that's what this drawing is showing. And obviously, the first recommendations that we start within the standard is to look at the risks. So we should be thinking about using a risk-based approach, because that's probably going to give us the most cost effective solutions. So there are many standards already around which can help us tackling this point or performing risk assessments for our facilities. So once we have identified our risks, the next recommendation is that then we need to identify the appropriate security controls or security measures to treat those risks as a second point. So that's again going back to the existing standards. There's quite a few standards already around, including nuclear specific standards, which provide recommendations for security controls. On the next step, the recommendation is that then the idea is that we use these security controls to inform the design of the systems. Effectively, we should be creating a security specification that is, for example, shared with our suppliers, and then the suppliers use that as an input to their design. Following on, obviously now we go into the suppliers stage, and we will be expecting them to use these security requirements alongside safety requirements to develop effectively an adequate design for our INC system. That's then implemented or manufactured. So we go on to the right side of the V life cycle then, and again we need to go into the validation process. So we're expecting at this point or recommending that not only we think about validating safety and functional requirements for an INC system, but also we include in these aspects or in these testing campaigns the validation of our security design. And then obviously the last phase is the validation of the initial requirements, which is usually done at different phases, but potentially during commissioning or during FAT, where again we are thinking we need to make sure that we include some aspects of validation for our initial security requirements to ensure that the system conforms with those. And then we go into the obviously operational and maintenance phase, and unfortunately or fortunately, I don't know, depending on how you look at that, cybersecurity, as we mentioned at the beginning of the webinar, is a changing topic, is a changing landscape. The risks are changing So probably for the rest of the station life, we will need to be going back to the beginning, assessing our risks and ensuring that the security design of our systems are still adequate to mitigate those risks. At the bottom line, obviously, there's some recommendations as we go along through the life cycle, to produce design justifications. We call them security cases. You could call them in different ways, but the idea is obviously that we put down into a document evidence of how or what risks actually we were concerned about to start with, and how we have, through the design of the ANC systems and other security measures, how we have mitigated them. And obviously that security case, as we say, will need to be maintained throughout the life of the stations, really. So there's always will be a need to review and update these security cases. Perhaps one of the things to say is that obviously this is presented as, perhaps, or could be interpreted, this is something only that could be applicable for new systems, because we are talking about initial requirements, design, implementation. But in my view, obviously, this approach and these recommendations that are mentioned in the standard can be also applied to existing facilities. Because at the end of the day, obviously, the risk assessment can be done even better if facility is operating, because we will be able to assess better the threats. We can always define the potential security controls that we would like to see in an operating system, and then we could effectively assess our existing operating systems to see if they comply with the security controls. And obviously, if not, potentially thinking about potential changes, or if we can do changes because they are already operating, clearly then thinking about some mitigation controls. So in principle, these recommendations are applicable for any type of system, whether it's new or whether it's already operating in a plant. And I think that's all I have to say in terms of the standards. And obviously, we'll go into a Q&A session, and I will be happy to address any questions.
All right, brilliant. Thank you very much there, Guido. That was very interesting. I think it was great to see that infographic with a little the other standards there as well. That really is very useful. I think it's really really interesting to obviously have the cybersecurity element, which is going to be more and more important, not only to maintain the operational safety and stability, but also when we're thinking about sort of scaling up in public trust, it becomes more and more important. Moving into the very brief Q&A session, can I ask both Guido and Robin to turn on their cameras? Oh, brilliant. Thank you very much. So we've got about sort of 5-10 minutes. I said we're going to go over a little bit. So probably a couple of questions that have come in. Robin, there was a question. Can you advise how safety systems are linked to the plant's system? And did you have any sort of thoughts on that?
So by safety systems, I'm assuming we're talking about C&I safety systems. So yes, clearly there's a clear link between what the plant physical systems are requiring and what their capability needs to be, and the C&I that helps support that. So there's a clear link. It's important to recognise the defence in depth when we talk about plant systems and safety measures, and the importance for those things to have sufficient independence and diversity to allow us to make sure that we have a safe plant. So the safety systems are similarly linked, and similarly it's important that we have the right independence and division within our C&I safety systems as well. So they're very, very, very interlinked in terms of both their functionality and in terms of the claims we make in the safety case. I'm not really sure how else to expand on that. Within the UK, there's expectations for independence, and within the UK, there's some expectations that we have to consider con mode failures, and therefore we tend to have both software and hardware based solutions within our overall design.
Yeah, no, thank you very much for that. I've got a question for you, Guido. the question is, what approach is recommended for aligning maximum acceptable cybersecurity risk versus maximum acceptable safety risks? Did you have any thoughts on that?
Yes, yeah. So I think in my experience on this, based on what we do, safety risks and cybersecurity links are really interconnected. So a safety risk can materialize to a cybersecurity incident. So effectively, when we do our cybersecurity risk assessments, the impact is part of the equation when we assess a cybersecurity risk. And obviously, as part of assessing the impact, we take into account the nuclear safety impacts of the nuclear safety risks. So effectively, they are interconnected. So then, how we can align or how we can accept, I guess, safety versus cybersecurity risks. I'm assuming that's what the question is saying. So there are already standards there which can help us, specifically the standard 62859, which is about coordinating safety and security. Explicitly already states that obviously nuclear safety is the priority. So whenever we are thinking about implementing cybersecurity, we need to ensure that cybersecurity does not compromise nuclear safety. But going back obviously to the short presentation I share with, obviously cybersecurity is an intrinsic part of the nuclear safety design.
Yes, there probably is a related question, which comes from Peter Bishop. I don't know who he works for, but he says, how do you resolve safety and security requirements conflicts? And I think you've probably mentioned it there already, but I just wanted to post that to you because you mentioned nuclear is obviously the sort of priority. But yeah, I don't know if you sort of wanted to expand on that or.
No, it was just to repeat what we were saying. So there is luckily there is a standard 62859 which provides some guidance on how to prioritize between safety and security requirements. It's a very good standard.
Yeah, you could almost work for BSI because when you can start sort of quoting numbers, that tends to be the sort of thing here in BSI where they can quote you any number. I'm not that good at that, I must admit. There's another live question from Robert Nicholson who says, will there be a question set or checklist which gives guidance to the cyber risks and how these potential incursions can be managed?
Yeah, I guess this goes back to when we say we need to identify the risks and then we need to identify controls to mitigate these risks. Unfortunately, that's where it goes back to the squareness of the people involved in performing the risk assessments and identifying security controls for the INC systems. There is definitely, again, there is another standard, nuclear standard, which I can quote now, which is providing the security controls for INC systems. I think 63096. Hopefully, I'm not very mistaken. And that effectively provides very good recommendations on what controls need to be applied, for example, on the INC system. But still, there will be a bit of competence required to then link them back to the risks. So yeah, I say it's not an easy question to answer, and it probably goes with experience of the assessors, and obviously they need to be experienced in the INC systems themselves to start with.
Yes, no, thank you very much. And probably, aware of time, I'm a terrible sort of chair. There's a couple more questions that have come in, so I'll ask those two questions and then we'll conclude it there. There's a question here, and forgive me if you don't know, we're getting to the limits of sort of my expertise, but does the standard support the development of FPGA-based protection systems? I don't know if you guys know. I can see you nod your head there, Robin. Did you want to come in there?
Yeah, again, without in danger of getting all my numbers mixed up, I think IEC 62566 covers FPGA or HDL based programmable systems. So there is a standard there that does cover FPGAs. The slightly more interesting challenge is how FPGAs are treated in terms of their complexity and their divergence from software, the ability to be able to argue diversity. That's a bigger area of research and debate within the industry. But yes, certainly there are standards out there now for how to design good HDL at different classification and reliability claims.
Yeah, brilliant. Thank you very much. And then the final question, which is quite an interesting one from John May, it says, in future, as more software is used throughout different parts of the plant, will this change the nature of safety and security case? It's possibly one for you, Guido.
Yeah, so it's so I was trying to understand the question. So it's about software being increasing in the plant.
I'd imagine so. So let me try and unpack that, because that's a problem with sort of audience questions sometimes. In future, as more software is used throughout different parts of the plant, will this change the nature of the safety and security case? So I'd imagine, yeah, as we start to digitize, like it's probably a question for the entire energy system, right? And I'm obsessed with this. I'm chair of National Grid's Virtual Energy Systems Data and Governance Task Force, and as we start to digitize, which is absolutely what we need to do, but as we start to do that, you obviously also increase the sort of need for cybersecurity. So I suppose that's the question.
The answer is yes. To be honest, is something that actually we already see in the new development. So in the new nuclear plants, most of the INC systems are actually software based. So it's a huge challenge. It's a huge challenge if we go back to what the standard is recommending that we do in terms of risk assessing and designing each system with security controls. Obviously, if we have a huge amount of INC systems because all of them are using software, it's going to be a huge challenge, and it's a huge challenge at the moment to deal with the cybersecurity topic. Yeah, and as we introduce software, obviously the security cases will need to be revised to ensure they are correct.
Yeah, it's an interesting question for us in the standards world as well, as to how do we keep up with some of those sort of rapid sort of changing environments, right? And that's why it's good that this standard is being revised, but it does pose some questions as new parts are being digitized. How do we sort of keep up? All right, well, I'm aware of sort of time. We said half an hour. We're 12 minutes over, so I think we'll look to conclude it there. I hope for everyone on the panel, if that was, or for all the participants, if that was useful and insightful. I've definitely learned a lot. So first of all, I want to thank you, the speakers, Robin and Guido. Thank you very much. That was a great session and really, really good. I definitely learned a lot today. I think you've really outlined sort of the challenges and sort of opportunities and the importance of this code of practice. I also want to thank you, the audience, for a very good session. Thank you for your participation and questions. For those questions that we can't get onto, we will look to see if we can answer those. And we will follow up with an email containing a recording of today's webinar. So thank you very much and have a great rest of your day.
Thank you. Thank you.